Hello students, good morning. Welcome to my lecture for class 11 science subject chemistry, Maharashtra State Board syllabus. In the previous lectures we have started chapter number 14, basic principles of organic chemistry. In the previous lectures we have studied about classification of organic compounds on the basis of functional group. In that lectures we have studied 16 functional groups. Now today we are going to study remaining functional groups. So let us start. Name of family. We'll start with tertiary amide. Now representation of this tertiary amide can be written as R CO R dash R double dash, where R dash and R double dash, they represent alkyl groups. They may be same or different alkyl groups. Now see the structural formula of functional group. It is written as, you remove this R, we will get the structural formula. Now see, the valency of nitrogen is what? 1, 2, 3. And you know the valency of carbon, that is equal to what? 4. 1, 2, 3, 4. And you also remember the valency of oxygen is what? 2. Now see the example. I am putting same alkyl group, CH3, CH3. Now we have to give the name to this compound. You remember that, see, this is the first methyl group, this is the second methyl group. Both are attached to nitrogen atom. So its name can be written as N dash dimethyl acetamide. This is the example of class tertiary amide. I hope you understood this. We'll proceed. Next one, that is class is what? Acid anhydride. Acid anhydride. See, anhydride is obtained when water molecule is removed from two acid molecules. Then you get what? Acid anhydride. See, it can be written as, if I have acetic acid CH3 COOH plus CH3 COOH. If you remove this water molecule, then what will you get? You get anhydride. See, it is written as CH3 CO, this O, then this CO, and this is CH3. So this is the example. Now how will you represent? See, its name is what? Its name is what? Acetic anhydride. This is the way to find the structure of acid anhydride. Now what is the representation? See, it is represented as R CO O CO R is what? Alkyl group. Now see the structure. Remove the R, CO O C double bond O dash. This is the structure formula of functional group of acid anhydride. And this is the acidic anhydride. This is the example. Observe this carefully. Now we'll proceed for next. Class is acid chloride. Acid chloride. The general formula or representation of the class is written as RCOCl. And see, the structure formula can be written as CO and Cl. So see the example. It is written as CH3COCl. The name of this compound is what? Acetyl chloride. Acetyl chloride. This is about what? Acetyl chloride. Now we will proceed for next. Note down this carefully. This is the structure formula of the functional group for the compound acyl chloride, or for the class acyl chloride. Next class is what? Sulfonic acid. General formula can be written as, or general representation can be written as RSO3H. Now see the how to write down. Structure formula of sulfonic acid, SO3H. Valence is also 6. Now see the example. I am putting C2H5 SO3H. Its name is not ethyl, it may be, or it is ethane sulfonic acid. One more formula we have, ArSO3H. It is, see the same example. Draw aromatic ring, attach SO3H, so it is benzene sulfonic acid. H. Now we will proceed for next. It is what? Class is what? Alkene. You remember in means what? Double bond. So it is written as RCH double bond CHR. There R means hydrogen or alkyl group. Functional group structure is what? Structure formula of alkyne is, you got this. Now structure formula for the functional group is written as this way. Now see the example. CH3 CH double bond CH2. It is called propane. Take one more example. CH2, or you can say H2C double bond CH2. It is what? Ethene. Ene means what? Double bond. Note down this. Now we will proceed for next. That is alkyne. YNE. It is written as RC triple bond CR. C triple bond C. This is the structure formula of the functional group for alkyne. See the example. Here is where R means H or alkyl group. ethane, which is also called as acetylene. Now last one is remaining. Last one is what? Very important, alkane. ANE. It is shown by RH. No functional group, so I put dash. Example, you know, CH4, CH3, CH3. CH4 means what? Methane, and this is what? Ethane. I hope you. Homologous series. You know, homo means what? Homo means same. So compound of the same class are included under homologous series. First you see the definition. A series of organic compound having characteristic functional group and each successive member of series differ from each other in molecular formula by CH2 means methylene group is called homologous series. You also remember each individual member of homologous series is called homolog. Now see the example. First remember a series of organic compound having characteristic functional group and each member differ by CH2 group is called what? Homologous series. These 2 points are important. They have characteristic functional group and each member is differ from each other by methylene group. Now see the homologous series of alcohol. We can take example of homologous series of alkane, homologous series of alkene, homologous series of alkyne, homologous series of acids, carboxylic acids, etc. I am considering homologous series of alcohol. In the bracket write down general formula, because each member of homologous series have same general formula. Is CnH2n plus 1OH. General formula of what? General formula of alcohol. Now see here. This OH is what? Functional group. Means they have common functional group and represent number of carbon atoms. Now see the member and its name. We will consider first homologue of alcohol. First homologue of alcohol is what? CH3OH. Its name is what? Methyl alcohol. If you add CH2 to this group, then what will you get? Add CH2. Then what will you get? CH3. You add CH2, that is methylene group. Then you get CH3, CH2OH. Its name is what? Ethyl alcohol. Now see third one. Again you must add CH2 group. CH3, one CH2, another CH2. So its name is what? N-propyl alcohol. N means normal. If any carbon chain contains more than 2 carbon atoms in a chain, then you put N. Now see the fourth one. Again you must add CH2 group. CH3, CH2, CH2. Add CH2. OH. Its name is, see 1, 2, 3, 4. Its name is what? N-butyl alcohol. N-butyl alcohol. Now here, what is the difference? See, first CH2 group, only one CH2 group. Here there are two CH2 group. Here there are 1, 2 and 3 CH2 group. So this is the homologous series of alcohol. I hope you understood this. And see, each member is called as what? Each member is called as what? Homologue. Now, if you consider ethyl alcohol, for ethyl alcohol is what? Lower homologue. For ethyl alcohol is lower homologue, and this is for ethyl alcohol, and propyl alcohol is a higher homologue. Then for this also higher homologue for ethyl alcohol. Means methyl alcohol is the lower homologue of ethyl alcohol, and N-propyl alcohol as well as N-butyl alcohol are the higher homologue of ethyl alcohol. I hope you understood this. Now we will study about types of carbon atom. Types of carbon atom. There are 4 types. First, primary carbon atom. Second, secondary carbon atom. Third, tertiary carbon atom. And fourth, quaternary carbon atom. Now see, for this you must remember one word. See, this is carbon skeleton. Now, this carbon atom is primary, this carbon atom is secondary, this carbon atom is tertiary and this carbon atom is quaternary. So we will study in detail. Now see, this carbon atom, it must be first carbon atom or which is attached to only one carbon atom, that is called primary carbon atom. See the example: CH3, CH3. Here, this carbon atom and this carbon atom, they are what? Primary carbon atom. Now consider second. See, this carbon atom is attached to one and two carbon atoms, so it is secondary. Again, see, you can see this is this one. This carbon atom attached to one and two carbon atoms, so it is also secondary. See the example: CH3, CH2, CH3. Here, this carbon atom is what? Secondary. Now see the third one. Here, this carbon atom is attached to 1, 2 and 3 carbon atoms, so it is what? Tertiary. It is what? Tertiary. So it is written as CH3, 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 Br. Here, this carbon atom is what? Tertiary. Now see quaternary. See, this carbon atom attached to 1, 2, 1, 2, 3 and 4 carbon atoms and 4 carbon atoms. So it is quaternary. See the example: CH3, C, CH3, CH3, CH3. Here, this carbon atom is what? Quaternary. Now, how do you define primary carbon atom? Primary carbon atom is the carbon atom which is bonded to only one carbon atom, is called as primary carbon atom, or it must be first carbon atom. Here, secondary carbon atom is what? The carbon atom which is attached to two other carbon atoms, which is called secondary carbon atom. Tertiary carbon atom, the carbon atom which is bonded to three other carbon atoms, 1, 2, 3. It is called tertiary carbon atoms. For quaternary, the carbon atom which is attached to four different carbon atoms, 1, 2, 3, 4. So it is called as what? Quaternary carbon atoms. So you must remember or how to identify primary, secondary, tertiary and quaternary carbon atoms. That is very important in order to study next part, that is IUPAC, nomenclature and common name system. So in the next lecture we will study about nomenclature of organic compounds. Thank you.